Cimarel here, and hopefully if you haven't, please go and first watch the videos in the Apex program. They are talking about horizontal asymptotes and vertical asymptotes, and they're also talking about taking limits, not just to a certain value, like let's look at what happens as a function's approaching 5 or looking at 2, but what happens if we take a limit going to positive or negative infinity? Okay, so that means instead of going to a certain value, I'm looking at what might be happening to a function as my x gets larger and larger and larger, or as it gets smaller and smaller and smaller. So as you've probably, since you've watched those videos, you know that a few different things could happen, right? For example, if I just had the graph of y equals x squared, okay, so I have a very simple quadratic, in fact the simplest that I can have, and looking at that quadratic, what would happen if x is getting larger and larger? Well, as x gets larger and larger, this just keeps getting larger and larger. So if I took the limit as x is approaching infinity, and notice how I said that, as x is approaching infinity, or I could say as x increases without bound, okay, that would be another way, or I could say as x becomes infinite. What's happening, it's also just getting larger, so it would be going to infinity itself. And what happens too as I get smaller and smaller, right, in the negative direction, same thing, I'm noticing that it would just be going to infinity. Okay, so that would be where taking the limit of infinity, I'm getting infinity itself. All right, now what would happen if I just looked at, say, a line? Let's just say I had y equals x. Okay, well, y equals x. We can already see visually as I approach positive infinity, it's just going to go to infinity itself. And if I were to go to negative infinity, well, it looks like it's getting smaller. It's going to negative infinity as well. Okay, so understanding what different graphs looks like will definitely help in you finding what its limit is going to be. Now, what else could happen? Okay, well, what else could happen could be that maybe it's approaching a certain value. It's approaching a certain number. And if that's the case, you might notice here I finally have, I got the TI-84 on my computer, and I've already gone ahead. I've clicked on my y equals. I would like you guys to do this as well at home. And I put in x squared minus 1 divided by x squared plus 1. Notice I have grouping symbols around this, okay, because my graphing calculator is going to follow order of operations. So if I don't put grouping symbols around that x squared minus 1 and then I do dividing by x squared plus 1, it's going to go x squared minus, I'm not doing that yet, it's going to do the 1 divided by x squared. It's going to do that first and then go back and do the minus and plus. So grouping symbols in the TI-84 are really important, okay? So protect your functions, wrap the grouping symbols around them so that you don't make that mistake. Okay, and I'm just going to go ahead and hit zoom, and I go down to number 6, which is the standard, and we can see the graph. So looking at that graph, we can clearly see that as it's going in the positive direction, it is approaching a certain number. And as it's going in the negative direction, it's also approaching, right, a certain number, and they look to be the same. Now, I could go to my table if I wanted to. I'm going to first go to second table set. And since I want to look at, I'm going to first look at what's happening as it's getting larger. So maybe I'm going to start at 0, and I'm just going to have it increase by, let's see here, 0, and then I'm going to have it, I'll just keep it, yeah, at that, that's fine. All right, let me go to my table. Okay, and I can start to, let's see, I can start to put in some numbers. Let's see, you know what, I still need to fiddle with this a little bit, okay, but I can already kind of see at 10, it's at 0.98. Okay, so even though I'd want to look at this with bigger numbers, and I will do that later, but I don't want to restart this video. So I could look at it with bigger numbers, and I would see that it's definitely approaching a certain value. All right. Now, I would also want to be able to figure this out without having to look at the graph of it. Okay. So if it's approaching a certain number, and if you watch that video, they talked about what they say a rational function. I'm going to go ahead and put the limit. So I'm over here on this side. So if I have the limit as x is approaching infinity, and I had 1 over x. Okay, and I know that they talked about this a lot, but this is a really important concept to understand, that if I have 1 and I'm dividing it by a really, really large number, and I think they called it the little big or the big little in the video, but 1 divided by a massively large number is just going to get really, really small. 1 divided by 100.01. 1 divided by a million, now it's really, really small. And the same thing if I was going to say negative infinity, if I do 1 divided by negative a million, it's just going to be getting really, really small. So the limit of this is going to 0. Okay, it is going to 0. And if I had 1 over x squared, same thing. Okay, 1, now it's just x squared. That's just even making that number even larger faster. Okay, it's going to go to 0. So that's an important concept with rational functions. All right. So what if I had something like this? What if I had a pretty gnarly looking function? Let's say I have the limit as x is approaching infinity, and I have, let's say I have 5x to the 4th plus a 2x minus a 1 over 2x to, let's say, x to the 4th minus 5x plus 2. Okay, so yes, I could graph this, and I would always encourage you, if you're not certain, to graph it. But I also can figure this out analytically. I can figure this out using, now I do know in the video they did a very long process. They said, go ahead and divide everything on the top by an x to the 4th and divide everything on the bottom by an x to the 4th, and then do some simplifying, and then use that property that I just talked about where 1 over x goes to 0. You can do that, okay? But that's a lot of work. Okay, thankfully there's a very simple way to do it, and you might remember a little of this from pre-calculus. I'm going to use what is called the dominating term effect. Okay, so these two terms right here, this term and this term, are going to dominate this expression. Okay, so the very top function, okay, this is going to dominate, meaning if I put in a really large number, this is going to be so large that these become insignificant. Okay, and same thing on the bottom. To help illustrate that, think about, I know you guys have heard of like the national deficit, that it's like billions and billions. I don't even know. It's a lot of money. Okay, so if I decided to give, I just thought, I'm going to help the US government, and I'm going to give them my $5,000 tax return this year, and I'm going to tell them to put it towards that deficit. Okay, that $5,000 is like nothing. Okay, putting $5,000 towards billions and billions is nothing. Okay, so that's where it becomes insignificant. Okay, it doesn't mean it's 0, but it becomes insignificant. So if x is getting really, really large, these terms are going to drop off. Now I'm not going to cross them out because mathematically that's not correct. We know that they wouldn't be cross-canceling. So I'm just going to go ahead and rewrite here, and I'm going to put the limit as x is approaching infinity, and I'm going to write those. Okay, so I'm just kind of looking at those are gone. And I'm also going to write next to it, and I would like you to do the same, DTE, which stands for the dominating term effect. That's what I'm using. And again, I'm only using this, let me clarify, with rational functions. Okay, if I don't have a rational function, I don't want to use this. Okay, now that I've done that, these do mathematically cross cancel and I get 5/2. Okay, so that's what's happening as it's approaching positive infinity. It's going to 5/2. Now if I change this and put a negative infinity, same thing would be happening with this situation. Okay, all right, let's look at another example. What if it wasn't x to the fourth? What if it was x to the third on the top? Well, notice I'm going to do exactly the same thing. These two terms would still be dominating. I would still write them down here. I'm going to still cross cancel. Only thing difference is now I'm not going to end up, they're not going to completely cancel out. So I'm going to end up with an x down here. So I'm going to have 5 divided by 2x. Well, right there, let me again visualize what's happening. As x is getting really, really large, okay, and let me even now think of it in terms of the negative infinity. Okay, well, as x is getting really, really large in the negative direction, like -1,000,000, I'm going to have 5 divided by -2,000,000. Well, that's really close to 0. And if I made it 1,000,000,000, now I have 5 divided by -2,000,000,000. Well, that's like really, really, really close to 0. Okay, so what's happening? This is going to 0. Okay, so my limit in that case would be going to 0, which would mean I would have a horizontal asymptote at y equals 0. That would be my horizontal asymptote. Okay. All right, let's look at one more possibility. Okay, well, what happens if, let's say, come on, erase, erase, erase. Okay, so what happens if, I don't know why that was so slow. Okay, what happens if this is a, let's make this a 6. And let's make this a 6. Okay, thank you. All right, sorry, bad 6 right there, but that's a 6. Same thing, okay, I'm going to have 5x to the 6 over 2x to the 4th. I'm still going to cross cancel. I'm going to end up with 5x squared over a 2. Okay, well, we talked about this at the beginning of this video. What's going to happen? Well, that's a quadratic x squared. I already know as it goes to negative infinity, it's just getting larger and larger because I'm squaring it. So this would be going to infinity. All right. All right, so those are the possibilities looking at horizontal asymptotes. I did not talk about vertical asymptotes. We will talk more about those in class. I hope that this helped a little bit.